Hey guys, this is the notes for 2.4. It's on complex numbers and their operations. We kind of talked briefly about this maybe before about if we were trying to find solutions that are actually not real solutions, and that's what this goes into. So, right off the bat, right, this just says example one, solve a quadratic equation using square roots. So, we're just going to solve by square rooting both sides. Okay, so if we look at the first one and we take the square root of x squared and 16, right, we can solve for x. Okay, so um, we can notice that 16 is a perfect square, so we can square root both sides and it will give us two solutions. Okay, the reason we get two solutions is because there are two roots, right? When we square root something, we get plus or minus that what we're taking the square root of. Okay, the perfect square, 16 is a perfect square, and the square root of it is 4. So we get plus or minus 4. Right? So our solutions for x equals 4, x equals negative 4. Right? And that's because, right, we're looking for a number that can be squared and give us 16. Right? We know we can square 4 and it gives us 16, but we could also square negative 4 and it will give us positive 16. That's why there are two solutions. That's why we have plus or minus whatever we square rooted. So I'll kind of write this, right? Square root gives two solutions. So remember that, right? Our answer is not just x equals 4. All right, now the next one, right? If we try to solve it the same way, we wouldn't be able to. The reason is because there are no there are no real solutions that can be squared and give us a negative solution. Okay, so there are no real solutions that can be squared and give us a negative number, right? Um, because whenever you square something, right, it becomes positive. So there are no real solutions. Well, how do we solve for this? Well, we use these things called complex numbers, right? And we'll go into this thing called imaginary unit. All right. Well, to solve these, right, what we're going to do is we're going to separate. We're going to separate 9 and negative 1, right? Then take the square root of them. Right? That's because we can rewrite negative 9 as a product of 9 times negative 1. Right? So we're going to rewrite this as x squared equals negative 9, 9 times negative 1. Then we're going to take the square root. Okay, so we take the square root of all three terms. So we get x equals plus or minus square root of 9 is 3, right? And then we have times square root of negative 1. Now, right, we have something that we can write for square root of negative 1. Okay, so this is important, right? Square root of negative 1, whenever you see it, it's equal to I. We're going to put an I. I stands for an imaginary unit. Okay, so we're going to take the square root of -1, and we're just going to put an I there. Okay, so whenever you see the square root of -1, you're going to put an I. So our solution is going to be x equals plus or minus 3 times I, or 3I. Okay, so this is what happens essentially when you have a negative number and you're taking the square root. You're going to get a solution with an I unit, or imaginary unit. That's because when we square root -1, it is equal to I, or an imaginary unit. All right, so right, for these ones again, you want to separate them. So make it x squared equals just 5 times -1, right? And then you want to take the square root of all of them. Okay, and then remember, square root of -1 is equal to I. So you're going to want to do this for this next one as well, right? I'm going to take the square root of x squared, 72, times square root of -1. So I'd like you to try these on your own, and then I'll quickly go through them. So pause this if you can. All right, so we can't take the square root of 5, right? But we can take the square root of -1 is I, right? So we get plus or minus I, and then what's left over is square root of square root of 5. And that's our solution. All right. The next one, all right, we know we can separate this as square root of 36 times square root of 2, right? So we can take the square root of 36, which would be 6. This was just I, right? So our solution is plus or minus 6I, right? And then what's left over is square root of 2, right? Because we can't take the square root of 2. All right, so that was kind of an introduction of complex numbers. And now this is like kind of the formal definition. So an imaginary unit I is the principal square root of -1, right? So when we square root -1, we get I. Now, right, opposite, if we square I, we end up getting -1, right? So, right, square root of -1 equals I, and then I squared equals -1, okay? So an imaginary unit is in any number bi where b is a non-zero real number and I is the square root of -1. Okay. Complex numbers are numbers that can be written in the form a plus bi. Okay. So you'll see a plus bi. Where a and b are real numbers and I is the square root of -1. They include all real and imaginary numbers, as well as the sum of real and imaginary numbers. Okay. So, for example, right, if we look at -6 plus 4i, right, let's label a and b, right? A is just -6 and b is 4. What if we had 7 minus I square root of 2? Well, your a is 7 and your b is negative square root of 2, right? It's anything that's not I in that second part, right? It's a plus bi. And if we have a minus sign, that means b is negative, and then square root of 2 is the number attached to I. What if we had just like 0.5 I? Well, your a is 0, right? We don't have a number being added or subtracted to it, and then your b is just 0.5. Right, so that's just for labeling purposes. All right, so now we'll move on to adding and subtracting complex numbers. Now, adding and subtracting complex numbers is very similar to like combining like terms. Um, Essentially, what we're going to do is just combine all the real parts and combine all the imaginary parts. And then when we get to taking the difference, right, it just be taking the opposite, changing it to addition, and then doing the same thing, right? So you want to combine all real parts and then combine all imaginary parts. And put in A plus BI form. Okay, so, right, we're taking the sum of these. Let's add our 4 plus our negative 11, right? That's our real, right? That's our real part. Imaginary, right, would be our negative 7i plus 9i, right? So, and then we put it in A plus BI form. We get what, negative 7 plus 2i. All right, so it's essentially just combining like terms. Now the difference, right? Subtraction. So we get, right, 6 plus 8i minus 2 minus 5i, right? So we want to change to addition, right? So we need to take opposite of second parentheses. Right, so distribute the negative to both of these. And we get 6 plus 8i plus negative 2 plus 5i. Now we can combine them, right? Put our reals together. So 6 plus negative 2 plus 8i plus 5i. And our solution, right, in A plus BI form. So we get 4 plus 13. I'll reiterate that. 13i. All right, so just find the sum or the difference of these two. So try A and B on your own. I'll pause it and then show you guys the solutions. So here are the solutions, right? The first one, just combine your reals, combine your imaginaries. Second one, change it to addition, then combine reals, combine imaginaries. All right, so now we're going to go into multiplying complex numbers. Okay, so we want to find out how we can write the product in the form A plus BI. Okay, so we're going to have to use the distributive property and distribute our outside term to both terms in our parentheses, right? So we get negative 2.5i times 8 plus negative 2.5i times negative 9i. Now, one thing to keep in mind in these problems, remember back, we said I squared is equal to negative 1. So, right, whenever you see I squared, you need to change to negative 1. Okay? And you'll see that in this problem. Right, so 8 times negative 2.5i is negative 20i. And then we get A negative times negative is positive. Negative 2.5 times negative 9 is 22.5. And then I times I is I squared. Okay, so we get negative from this multiplication, we get 22.5 I squared. Well, remember, we said we're going to change I squared whenever we see it to -1. Right, so we get negative 20I plus 22.5 times -1, which is negative 20I minus 22.5. And then we just want to put it in A plus BI form, so the I's one comes second, right? So we just have negative 22.5 minus 20I. Okay, so the biggest thing is making sure when you have I squared, you change it to -1. All right, so the next one is multiplying two binomials, right? So we need to use the FOIL method. Okay, so we get 3 times 3 plus 3 times 2I plus -2I, right, times 3 plus -2I times 2I. So let's clean this up. We get 9 plus 6I minus 6I minus 4I squared. And again, we have an I squared here. We need to change to -1. Right, so we get 9. When we combine these, right, we get plus 0, right? Then minus 4 times -1. We get 9 plus 0 plus 4. And we actually just get 13 as a solution. So we can see the i's canceled out, and then we change I squared to -1. We actually get a product in this one, okay, as 13. All right, so I'm going to have you try the next two on your own, then I'll go through the solutions. So have you pause this, try these on your own, and then we'll go through the solution. Okay, so in the first one, right, we have to use a FOIL method. We end up getting, at the end, we get an I squared, right? Change it to -1. So we end up getting -5 there. Combine it with the -12, we get -17. And then our i's are -28I. So -17 minus 28I is our solution. The next one's just distributive property. Just distribute the 2I to both terms, right? This becomes -1, and that's where we get the -6 here. And then bring the plus to, because we always want an A plus BI form. Okay, and that's the end of our notes.